Hello, 안녕하세요. My name is Henry Tsang, and I am an architect and assistant professor in the REAC Center for Architecture at Athabasca University. At Athabasca University, we respectfully acknowledge that we are on and work on the traditional lands of the Indigenous people, Inuit, First Nations, Métis of Canada. Today, I am speaking to you from Calgary, Canada, and I will present about global trends in green and resilient architecture and public design. According to NASA, as of today, the global temperature has risen by 1.8 degrees Celsius since 1880. CO2 levels in the air are at its highest in the last 650,000 years. In consequence, Arctic ice is diminishing, ice sheets are melting, and sea levels are rising at an alarming rate. On this map, you can see the regions most severely affected being concentrated in the north. The Global Carbon Project states that cities account for more than 70% of our CO2 emissions. Emissions from cities vary greatly depending on land use, energy consumption, and a variety of socioeconomic and geographical factors. 3 points to note here. Firstly, it is agreed that there are three main contributing sectors to CO2 emissions, which include 1, buildings, commercials, and residential; 2, industry; and 3, transportation. Secondly, given that world population is still growing and more people are moving to live in cities, urbanization will continue into foreseeable future. So thirdly, this process will increase emissions unless cities take action to reduce emissions through architectural and urban planning, new technologies, and behavioral changes. As previously mentioned, the building industry and industries and transportation sectors contribute to emissions of CO2. Most importantly, buildings, construction, and operation account for approximately 40% of global energy use and energy-related greenhouse gas emissions. In Canada, this accounts for 45%, and in Korea, it is even higher, around 56%. As a result, a move towards greener, more sustainable, and regenerative design will have a huge positive impact in the reduction of greenhouse gases and slow down climate change. A green building is one that consumes less energy through the efficient use of resources. They possess a smaller carbon footprint than its energy-hungry predecessors. However, designing green buildings is only one step in the right direction, but a necessary one. Green buildings help reach the UN Sustainable Development Goals. And on this slide, you can see the intersectional benefits of green buildings that range from improving health and well-being, promote renewable energy, boost jobs and economy, spur innovation and contribute to climate resilient infrastructure, become the fabric of sustainable communities and cities, apply circular principles, contribute to reducing carbon emissions to combat climate change, help improve biodiversity, and become the bond to create strong global partnerships. In designing a green building, these are the categories included in design frameworks, which include energy and atmosphere, water efficiency, sustainable sites, location and linkages, innovation and design, awareness and education, indoor environmental quality, and materials and resources. An endless number of green buildings doesn't make a sustainable city, said the Danish architect Jan Gehl. In fact, just designing green buildings is not enough to be sustainable. We need to aim for net zero carbon and beyond, which can be achieved through the careful orchestration of the holistic systems of the city. World targets to meet net zero are scheduled for 2030, during which all new buildings must operate at net zero carbon. And in 2050, during which 100% of buildings must operate at net zero carbon. 4 key principles are proposed by the World Green Building Council to achieve this target for buildings, which is 1, to measure and disclose carbon, 2, to reduce energy demand, 3, generate balance from renewables, and 4, to improve verification and rigor. So this is the first project I would like to introduce to you is one of my recent designs for the Calgary Japanese Community Center in Canada. The design takes into account the local residential context in a suburban neighborhood. The massing of the building recognizes the scale of the surrounding buildings. The shape and materiality of the building is studied to reflect the local vernacular architecture, but also as a community center for an ethnic Asian group. There was also deep discussions on cultural understanding prior to the design to properly reflect the cultural identity of the building. As a design, it introduces a central courtyard in the middle that is accessible and open to the public. This is a space that contributes positively to the neighborhood as a garden and place of respite. It is vegetated by indigenous plants, acting like the lungs of the building by absorbing the CO2 and providing fresh air. The green design strategies are complemented by passive and active design techniques here. Passive solar design approaches optimizing the sun dictates the geometry of the roof. The roof twists according to the sun path. At the ground level, it is open for views inside and outside, but also allowing natural light to penetrate deeply into the rooms to optimize light and heat. The building material is mass timber, so it reduces greatly the embodied carbon footprint of the structure. And an earth tube system provides the building with naturally ventilated air through underground tubes. Water is also retained for irrigation and gray water. And active design approaches include the introduction of solar PV panels, as well as sensors that control the turning on and off of the lights. From the entrance, the building is inviting, open, and well lit. This increases safety when visibility is well ensured. The building is also designed to be well equipped for bicycle users with bike racks, but also accessible via public transportation and walking, while discouraging the use of cars as much as possible. The building is also designed to be as flat as possible so that it is accessible to wheelchairs, wheelchair users, and seniors. Canada has a large aging population, therefore, barrier-free universal design will also contribute to providing dignity and equitable accessibility in public buildings and spaces. Moreover, consideration of views and biophilic design greatly enhances health and well-being for people using the building. Particularly with the COVID-19 pandemic, we are spending over 90% of our time indoors. Therefore, physical and mental health in buildings are serious issues to be considered. Similarly, this is my design for an outpatient clinic for the San Felipe Hospital in Honduras. Using the same strategies of integrating nature, providing openness, visibility, understanding and preserving culture, and ultimately focusing on a human-centered design. As a result of global warming, occurrences of natural disasters has more than tripled in the last 30 years. over 800 million people living in 570 coastal cities around the world would be negatively affected by rising temperatures and sea levels projected at 30 centimeters by 2050. This is the case for the Korean Peninsula, where coastal cities such as Busan and Jeju are already experiencing an aggravating number of typhoons and floods over the past several years. As a strategy, designing for disaster resilience is to respond to 4 phases of the disaster, which is number 1, the response, number 2, recovery, number 3, preparation, and 4, mitigation. In 2011, I designed the University of Indonesia's Health Science Campus. This project was a public project in support of the nation following the devastating Sumatra tsunami in 2004. The project was for a university teaching facility as well as a hospital. This project was particular as it was the first of its kind in the country that was designed to be a top-notch green building, as well as a resilient building to natural disasters. The design team from Nihon Seiki Architects collaborated closely with the university and health ministry for over 2 years to develop the scheme. The resulting design was a modern interpretation of architecture in the tropical climate of Indonesia. For passive design, large spanning green roofs provided cool shading to the campus. Vertical green walls also provided fresh, clean, naturally ventilated air. And for active design, the project utilized solar PV panels, and it also reused the gray water captured from the roofs and the rain. Culturally, the project emulates the geometry of the existing traditional campus buildings while bringing a modern interpretation to the architectural style. For resilience, the structure of the building utilizes base isolation techniques that allow the building to float on flexible columns so that the building can be shaken by earthquakes, but return to its original position. Off-the-grid power generators also allow the building to continue to function in case of a power failure. So I lived in South Korea between 2015 and 2019 as a professor at Keimyung University. At the time, I was involved as an advisor and jury member to 2 major international design competitions in Korea. The first project is the Gangnam Intermodal Transit Center project. And the winning proposal was submitted by a French architect by the name of Dominique Perrault Architecture. And this is a quiet, subdued proposal that tried to balance the busyness of the district. Most of the building is underground, making place for a large outdoor central park on the ground level. This provides an interesting human-centered public space rather than give way to the cars. The functions of the building include a highly complex transit terminal for buses, trains, and cars. Therefore, I think this project that proposed a green, tranquil, and iconic design provided what is needed for this context. The second project I was involved in is the regeneration of the Tongyong Dockyard project. This project's aim was for the revitalization of an abandoned shipbuilding dockyard. The winning proposal by Hen and POSCO ANC proposed an urban planning design that celebrates the culture and identity of the site as a dockyard. Here you can see the architects reutilizing some of the abandoned cranes and warehouses, reimagining them into different functions such as a stage, a market, and a makerspace. This project also proposes a sensitive approach to culture, identity, as well as preservation of the site, which I believe was an appropriate design for this project. So finally, I would like to summarize some of the main strategies in the design of green and resilient architecture and public design. Number one, to create harmony with the natural and built context. For a green building to be sustainable, it needs to respond to the natural environment that surrounds it, such as the sun, the wind, and the climate, and optimize the use of natural elements through passive design. This needs to be complemented by active design and smart technology. It equally needs to respond to the built context, such as other buildings, infrastructure, roads, etc., in creating a synchronized system. Number two, to preserve and embody local culture and identity. Every place has a local culture and identity, and a good design would seek to preserve and enhance this through discussion, understanding, and public engagement. Number three, enhance the feeling of safety and dignity. A good design should make one feel safe through well-lit and visible spaces. One should also feel dignified through the provision of privacy, as well as equitable treatment and access to spaces, such as with barrier-free universal design. Number four, to promote health and well-being, buildings need to first do no harm by eliminating toxic materials, but moreover, contribute to the health and well-being of users with quality air and indoor environments. Number five, to focus on people, human-centered design. Buildings need to design for people first, and the design should also respond to the human scale and the perceptions of space. So with this, I would like to conclude my presentation. Thank you, and 감사합니다. I would like to take any questions if there are any, and thank you very much.